Mics, if that's okay, gents. Hi, I'm Trent Parado, Public Affairs Officer at NASA Headquarters. Welcome to today's NASA social media chat for the Orion Multipurpose Crew Vehicle. We've had a great event this morning here at NASA's Kennedy Space Center in Florida to recognize the arrival of the first space-bound Orion spacecraft, the one right behind me. We're excited to have this opportunity to answer your questions at home about America's next-generation spacecraft that will carry astronauts farther into space than ever before. We've had a lot of great questions come in so far this morning on the comment threads of NASA's Facebook and Google Plus pages. For those of you following on Twitter, you can ask your questions of the panelists by using the hashtag #AskNASA, and we'll get to as many as we can over the next 45 minutes. The spacebound Orion, behind me, will launch on Exploration Flight Test 1, an uncrewed mission planned for 2014. This will travel 3,600 miles above the Earth's surface, 15 times farther than the International Space Station's current orbital position. This is farther than any human spacecraft has gone in more than 40 years. This flight will help prove that Orion can survive the enormous speeds and heat generated during a return from deep space. We have a distinguished panel of participants here to answer your questions about the spacecraft, the 2014 EFT-1 flight, and the future missions Orion, the Space Launch System in development, will enable. I'd like to introduce them now. First, we have Mark Geyer. He is NASA's program manager for Orion. Essentially, he's the person managing the huge effort at NASA that's building and delivering the spacecraft that you see behind us and the team that'll turn it into a fully operational spacecraft. Next, we have David Beeman, the NASA Space Launch System spacecraft and payload integration manager. He's part of the team working on America's next heavy lift rocket. It's going to provide an entirely new capability for human exploration beyond low Earth orbit. For more information about SLS, you can get all the facts at nasa.gov/SLS. Next, we have Pepper Phillips, the NASA Ground Systems Development and Operations Program Manager. Ground Systems here at Kennedy is leading the transformation of this launch complex to a next-generation spaceport bustling with government and commercial activity. And next, we have astronaut Rex Walheim. He's the astronaut office's main liaison with the Orion program. In that capacity, he provides input from his unique perspective as an astronaut throughout Orion's design and testing process. He's a veteran of 3 space shuttle flights. This includes being one of the 4 NASA astronauts to fly on the final shuttle mission, STS-135, nearly a year ago. So, we're going to jump right into your questions, and we've monitored quite a few that came in this morning. I'm going to take the moderator's privilege and ask the first one, if that's okay, because I'm guessing it's on your minds at home, too, and it's Mark Geyer. Why is your spacecraft green?
I had that same question a few years ago. Basically, it's a coating, it's a primer. You can think of if you had a car or other metal pieces, you like to put a primer on it, protects it against corrosion and other things. It'll be covered, so when we fly you won't see the green. We're actually going to have tiles on the back shield that will be black. Part of that is part of the thermal protection that we use as Orion comes back in. And the heat shield itself on the bottom will be white. So all of that has to do with understanding how we want the thermal properties to behave and then what coatings we're certifying for flight.
Okay. All right. So the first question we're going to take from the public comes to us from Facebook, and it's what makes the Orion capsule suited for deep space exploration? Would ever like to take that?
Start. Couple things because of the long duration that it's going to have, and we have 4 people. 4 people are the mission that we have. So the longer you're out in space, the more stuff you need: food, water. Also, the crew requires suits and other things. Longer duration will actually require a toilet, those kind of things. So that increases the volume. So the volume is bigger. The longer duration the crew is going to be out because, again, the stuff that they need to survive. Also, long-duration missions require, or the missions further from the planet require more propulsion tanks, so forth. So the Delta V we use to get us around drive the size of Orion as well. There's a lot of things that you don't see in the structure that would be in the avionics, the computers, and other things. As you get further and further from Earth, you want your reliability. Quality is much more important because failures and issues a long way from Earth are a lot harder to recover from. So those are the kind of things I think are big drivers for us. Radiation shielding is another one. This structure, of course, is a big part of that. And there are other things we do for the crew when they're a long way from Earth to protect them for that.
Got it.
Rex, did you want to? Okay.
Well, let me go. Let me ask a related question, actually, for Rex, and it's something that I saw on Facebook this morning too. And you described how the spacecraft will function and some of the considerations we need to make. But a more pointed question: how will astronauts be able to maintain muscle mass and bone density aboard Orion? How are we preparing for?
It'll be fairly similar to what we do in the International Space Station. We'll have resistive devices and then potentially some kind of ergonomic device. And it's very important, and that's one of the most important things we're learning from the space station is how to survive in space, how the human body can withstand 6 months, a year possibly, and even longer. And so what we're learning on space station, we've developed some effective countermeasures, how to stay in shape, how to maintain your muscle mass, and we'll incorporate those lessons into this vehicle.
Great. All right, next question. Any plans to make Orion compatible with the International Space Station docks in case of an emergency need to dock?
Part of our plan is to be potentially a backup in the unlikely case that maybe the commercial crew guys are not able to perform that function. So it turns out a lot of the Orion requirements are the same. We have the capability to dock. We can carry people. We have the propulsion capability to do that. So we would need to give us a couple of years to change our plans to put some things like a rendezvous and docking sensor on Orion, which of course we have the capability to do. So we can do it, but I think the way you said it is right as a backup, because really it's built for exploration. It's, as we talked about, it's bigger because of exploration, so it's not as an efficient an ISS transport vehicle. But we can be ready as needed, if we need to be called up.
Okay. Direct this question to Pepper and to David. What sorts of challenges, technical, communication, et cetera, essentially, as we look to send astronauts to and from deep space here from Kennedy, how do you have to approach that differently than you've ever done before as you prepare SLS to launch from here, as you prepare ground systems to be able to support SLS? What's different this time around when you're looking at a farther target, like somewhere in deep space?
Okay, well, I think we have some experience in going to the moon, and we're going to take advantage of that. One of the biggest challenges that you have is having good, safe, and reliable access to deep space. You talked about the physical aspects, making sure that the health of the astronauts. You have to have redundancy. You have to make sure that if you put a crew out there, you have the ability to get it back. Part of that is the launch vehicle, and part of that is the spacecraft itself. So, it drives our design time, it drives our test time, and we want to make sure that we have the safest, most reliable system out there.
And for us, for the ground, it's much like our processing is just like we do for shuttle or any of the other spacecraft we've launched from here. Our job is, if there's going to be a failure, let it be on the ground. Reliability is a big deal for these guys. We want to make sure the testing, the checkout, the things that we look at on the ground are complete, satisfy the criteria that the designers designed the vehicles to, and then we're ready to go.
Okay. Next question came in from Twitter. What is the predicted date of an Orion manned space flight? And actually, can you give us a little more detail on it? What it is that we're looking forward to?
Yeah, good. So we have this flight test first in 2014. We have an abort flight test that we're working on the date, probably around the 2017 timeframe. That'll be done out of Florida. Our first big test with SLS will be in 2017. It'll be unmanned because we want to flesh out the systems, the integration with the rocket, unmanned before we actually put people on board. So those have to happen first. And then we have a lot of tests on the ground to qualify, ECLS, displays and controls, other things, seats that are part of launching people. So beyond 17, that date is really driven by the budget. We're working with headquarters on exactly what the budget's going to be. It's a few years out. Today we're projecting probably in the 2021 timeframe. I believe we can do better than that, and that's what we're trying to work on, accelerating those dates.
Okay, all right. Let's see. We'll do for David. Question from Twitter. Your SLS is going to take us to deep space, carry the Orion spacecraft there. How much farther outside Earth's orbit is that? What's your line? Where are you aiming? What's the boundary for you?
Well, obviously, I think the first goal is to go around the moon with the first two early missions, and we'd like to have a manned Mars mission. A lot of discussion about going to an asteroid. That's one potential, but I think near term we want to repeat the success we had previously going to the moon. We want to make sure we provide Orion with the test flights that they need to prove the deep space capability, and then really, the planets, the stars are the limit.
So we know space starts about 100 kilometers. Is there a measure when you're talking deep space? Is there a certain kilometer measure that you're using? Say SLS needs to get us this far.
I really don't think that, because I think relatively speaking, that's a whole lot closer than we want to go. When we talk deep space, we're talking Mars, we're talking an asteroid, and I think the dividing line between a low Earth orbit and deep space, I think, is a whole lot closer than we want to get as an agency.
All right. Here's a fairly technical question from Facebook. Will the service module be adapted to carry mission-specific payloads, such as planetary science, Earth observation, or astronomy instruments?
So from the beginning, we designed the service module to have cargo carrying capability with a two-tank configuration. So depending on what propulsion delta V you think you need, we can actually carry quite large payloads. In the 4 full tank configuration, like the one we're sending on our flight tests around the moon, we still have volume that can either be attached to the side of the service module, or actually could be areas that we could extract from the bottom. So we are looking at that very closely, because I think it's extremely important to be able to have payload capability, experiment capability. Since we're going to these far places, those payloads will actually give us a lot of capability to understand the planets.
Just a reminder for those of you watching at home, if you're on Twitter, you can ask your questions of the panelists by using the hashtag AskNASA. If you're on Google Plus and Facebook, just look for the comment thread that we have going and put your question there. We have a team getting us the questions just as quick as you're putting them in. So the next one comes from Twitter, and that's it could be Mark, could be Rex. It's an interesting one. Why did the shuttle fly a manned first test flight, and why are we planning an uncrewed test of the Orion capsule first?
It all depends on the capabilities of the system you're developing. What you'd like to do is, if you have the ability to test something unmanned, it's the safest way to do it. And so with the shuttle, they deemed as it got closer to launch that having the presence of people on board was the best way to do it. They couldn't automate the landing sequence in time to be able to put people on, to be able to do it automated for the first flight. So it took a lot of guts and courage to send those two guys, John Young and Bob Crippen, on that first flight in a manned configuration. But if you can test these out unmanned and automated capability first, that's the way you want to go.
Anything to add, Mark? Okay. Got it. Okay. What scientific fields will be necessary for deep space human exploration? What do you have to learn now scientifically that's going to enable human travel?
Rex has actually been up there, so why don't you start with that?
Okay, for what kind of field you might want to have on a deep space mission? Well, it's going to be a little bit different. From the low Earth orbit, we were building the space station. And we're operating the space station. You have a wide variety of backgrounds, from engineers to scientists to pilots. You can have the same kind of core background for deep space missions, but you're also going to need a more heavily geology-based field of knowledge or training. And so we're actually looking at that in the astronaut office. We're training our astronauts to be better geologists. We're looking at prototype programs, and we did that in the Apollo program. We're going to have to get back to that, because the really important thing about manned spaceflight is you have curiosity. You have a knowledge base they have when they get there, and they have a curiosity when they get there. They can be trained all about geology and told, okay, this is where we want to look at. But when they look to the side a little bit and see something different, they say, that's odd. Those are where some of your best discoveries come from. So we'll try to have a little broader training in geology and some of the planetary sciences, and I think that'll help us out a lot.
And I think a lot of the technology that we need to send people further in space, we're learning a lot on space station. So the long duration, a great question on the bone mass and other things, which was a huge uncertainty until space station, where we've learned a lot about what exercise equipment can do and help. Radiation is another one. We understand what the environment is like. How can we protect the crew better? What are the real effects? That's another one that I think we're pushing the envelope on. Two good examples.
So David, how about on the SLS side? And this is a sort of related question from Twitter. What innovations do you have to do on your end to sustain human life as we go out into deep space? How are you designing the launch vehicle with that in mind? What innovations do you need to make?
Okay, and I think there's a couple of areas that we have to cover. You have